Welcome to EDU World Space.
Problem 3.135. In this problem, we have to replace the moments and forces that are acting on the system by an equivalent range, and we have to determine the resultant force that will be acting on the system and pitch of the range and point of intersection of the range axis with XZ plane. So first of all, we will try to find out the equivalent force that is acting on this system, and equivalent force acting on this system, let's say R, can be found by adding the total forces that is acting here. So this 15 Newton is in negative y direction, so this will be minus 15 J cap, and 20 Newton is along the negative x-axis, so it will be minus 20 I cap. So equivalent force comes out to be minus 20 I cap minus 15 J cap. If you want to find the magnitude of the equivalent force, it will be under root of minus 20 whole square plus minus 15 whole square. So it comes out to be 25 Newton. Alright, if you want to calculate unit vector along the equivalent force, so that can be found by dividing the vector that is equivalent force by its magnitude, and that will be minus 20 I cap minus 15 J cap divided by 25. So it comes out to be minus 4 by 5 I cap and minus 3 by 5 J cap. So unit vector along the equivalent force is minus 4 by 5 I cap minus 3 by 5 J cap. Now if we calculate equivalent moment about O, so this will be, since 1 Newton meter is acting along negative y axis, so it will be minus 1 J cap. This 4 Newton meter moment is acting along negative x-axis, so it will be minus 4 I cap, and this 15 Newton is passing through the origin, so its moment effect will be 0, and this 20 Newton is at a distance 100 mm. So all the units are in meters, so we will convert this 100 mm into meter, so it will be 0.1 meter. So moment because of this 20 Newton force will be position vector, since this is going to intersect the z axis here, so it's let's say this point is D, so the position vector of point D will be OD vector, and that will be 0.1 K cap. So we can write the moment as 0.1 K cap cross multiplied with the force vector that is present at the point D, and that will be 20 Newton in negative x-axis, so 20 minus I cap. So now we can solve this. This will be minus J cap minus 4 I cap, and K cross I will give J, and one negative sign is there, so it will be minus 2 J cap. So if we solve this, collect the coefficient of I cap, J cap and K cap, it comes out to be minus 4 I cap minus 3 J cap. So this is the equivalent moment that is present at origin. Now if we calculate the magnitude of the equivalent moment, so it will be under root of minus 4 square plus minus 3 square, and it will be 5. And now we want to calculate the unit vector along the equivalent moment, and it will be equivalent moment divided by magnitude. Equivalent moment is minus 4 I cap minus 3 J cap divided by 5, and it comes out to be minus 4 by 5 I cap minus 3 by 5 J cap. So if we observe the lambda r, that is a unit vector along the equivalent force and a unit vector along the moment, both are same, minus 4 by 5 I cap minus 3 by 5 J cap. Here also minus 4 by I cap minus 3 by 4 J cap. So we see that since lambda r is equals to lambda mo, that is unit vector, it means that both the vectors are parallel. It implies that both are parallel and both are in xy plane, since only I cap and j cap component is involved. So first we had to find in part A the resultant force that we had already found here, that is minus 20 I cap minus 15 j cap. So we can write the answer for part A, that resultant force will minus 20 I cap minus 15 j cap. And in second part they were asking the pitch of the range. So pitch of the range can be calculated as, since both the vectors are parallel, so we can directly divide the magnitude of the equivalent force at origin divided by magnitude of the equivalent force present, and mod of MO was 5 and mod of R we had calculated here was 25 Newton. So we can divide it by 25 and it comes out to be 0.2. So pitch of the range is 0.2. And in third part they are asking to find the line of action of the line of action for this range, that is where it intersects the xz plane. So let us draw the coordinate axis here. So this is our x-axis, this is y-axis, and this is z-axis. Since we see that the line, the moment vector is along, unit vector is along minus 4 by 5 I cap minus 3 by 5 j cap. So it is in completely in xy plane, and let's say this is the line along which it is acting, and let's say this is making an angle theta. So theta can be calculated as, since the vectors are given in x, this was the y component and this is the x component, so tan theta can be calculated as the y component of the unit vector divided by x component of the unit vector, and y component is minus 4 by y component is minus 3 by 5 and x component is minus 4 by 5. So from here we get the value of theta, which is 36.87 degree. So for part C we can say that the range axis intersects the xz plane at origin and it is parallel to a line in xy plane which is making an angle (36.87 degree) with positive x-axis.